So like, again, I'm going to click through, like I'll just pick one of these and then I want to definitely find one that talks about the asymptotes because that's a huge one. And that's if you don't know how to tackle the asymptotes, then there'll be like a bunch of problems that you'll miss like 100% of the time. So, all right, let's get to it. So stuff like this, I know the hyperbola has a center at -1, 1, so I'm going to sandbox click this -1, 1. And then I know it has a vertex at -1, -8. So I'm going to head down to -1, -8. And so what do I already know like right now? I
A
know a
seven,
bunch. What's A?
7,
You want to try that again?
or
So I know already based on this, if I know that the center is here and that the vertex is way down here, A I know is 9. So what I do when I'm working these problems is I just keep a note card or a piece of paper or something handy and I just write down everything I know. So as soon as I know something, I go, boom, done. Thank you very much. Now, if that was all I knew, I'd be out of luck. But what else do I know? And it's not necessarily anything that has to do with numbers, but what do I know right now?
it opens up
It
down
opens
below.
up and down, and that's important because that's going to determine which flavor of the equation we use, right? So the fact that the vertex and the focus are located vertically to each other, then that means that somewhere, um, somewhere down there below there's a focus, but the bottom line is the graph goes down and up. And that means that we're going to pick the flavor of the equation that has the y minus k squared first. Okay? So you get a lot of information from very, very little stuff. Like that's just two stupid points, and we already know A, and we know which version of the equation to use. And even if that were all we knew, we'd still be out of luck, right? We know the center. That's worth writing down. Do we know the center?
Yeah,
Was it literally given to us?
-1.
So
Mhm.
what's the only missing piece right now that I need to finish this problem?
B.
I need B. So I'm going to look up now and see if did I get lucky and did they give me a covert text? Because if they did, then they essentially just gave me B. And they did. They might have, in another circumstance, they might have given me a focus. And in that case, then they're being a little bit harder and saying, I'm going to give you C, sucker, you got to go find B all by yourself, right? So the covert text is going to give me B, and that's going to be the covert text is right over here. So what is my B value? It is 5. It is, again, as it has been, quite literally the distance from the center to the covertex, right? So we can now say that B is 5. And the key here is to just bring it all together. The four numbers on the board that you just can't do without are the X and the Y of the center and the A value and the B value. And then you have to be aware enough of what it looks like to be able to pick the right flavor. So, and these are easy to miss just because we can I don't know, miscount things like when we look at the graph, miscount a number or a distance, like how Zach tried to tell me earlier that A was 7. Like things like that happen really fast if we're not careful. So I'm going to start by writing my y minus k squared. So that's going to be y and then what?
-1.
-1 squared. And I don't like to worry about the over stuff yet. I just like I did with ellipses, I just like to go minus and then build another fraction. And what's this going to be?
X+1.
X plus 1 squared, and then it always equals 1. And then you have to remember that A and B do not switch places, right? You got that from maybe from me, but mostly from that video that it's the Y and the X that are switching places with ellipses, not the A and the B. So A squared always goes first. So 81 goes here. Has nothing to do with that he's bigger. Doesn't matter. And then the 25 goes here. And then we're done. I can tell you for me what I did because I was blowing through a bunch of these probably faster than I should have earlier, just because I wanted to make sure there weren't any surprises around the corner. What I did is I typed in the answer. So like I went down here and I did what I always do. I went fraction, arrow, arrow, minus fraction, arrow, arrow equals 1, like this. And then I typed in an answer and I'll show you after this. So it's y minus 1 squared over 81 minus x plus 1 squared over 25. And before, oopsie, my bad, over 25. Before I hit send on this, this is a nice trick for you guys. If you get to going quick, I just highlighted all this and just hit Control C. And that's a keyboard shortcut for copy. So that way there, when you get to the next problem, and let's say you don't have anything in the box, then you can just go Control V, paste it in, and then you can just go back and change X and Y and a few numbers and saves you a little bit of time. So let's do another one. So I'm going to search until I find one that has asymptotes, just because I really want to talk to you about this. So if you're not paying attention, you should for this. I saw some of you are still kind of multitasking. This is the one that I really wanted to make a recording for. This was entirely the impetus for wanting to talk to you today. Um, so we're going to start by sandboxing in some points. So we have covertices at negative 2, 2 and negative 14, 2. What do we already know?
That's gonna open up
It's going to open up and down because the covertices are sideways, so the vertices have to be vertical. What else do we know?
B.
Well, yes. What else do we know? Where the center is. I mean, there's so much information to be obtained from such a seemingly small amount of information. Like, holy smokes, dudes. So, like, yeah, they only gave me these covertices, but we're not idiots. We can figure out then that the vertex is in the middle. And so from this now, I can write down a ton. I can say, and again, if you're not following along with this one, you really should be. I can say that the center is at negative 8, 2. And I'm seeing that like with my eyeballs, right? I just place it right between the two, and then I could just name it. And then I can also say what B is. What's B? Because B is the distance from the center to the covertices. What is that?
Four, five, I can't see, but yeah.
It is 6, right? And this is the part where I would need someone, if I were you, to explain this to me, I think. I don't know. I just wouldn't come up with this on my own. But the key here is to remember that with so the symbol I like to use when I'm writing on my own is I don't sketch the hyperbola. Like with ellipses, I always said if it's sideways, I just sketch this. If it's vertical, I just sketch this. With hyperbolas, because I don't like drawing them, I just cheat a little bit and I just say um, it's either this or this. Okay. And so that's my sort of shorthand notation to myself to keep track of pointy uppy downy or point lefty righty. And like Zach pointed out, this one for sure is an uppy downy hyperbola because if the co-vertices are left right, the vertices are up down. So knowing that it's an up and down hyperbola, I'm going somewhere with this means, and you'll want to look on your resource sheet unless you've already memorized this, what are the equations of the asymptotes when it goes up and down? More specifically, what are the slopes of the asymptotes when it goes up and down?
So plus or minus A over B.
That's what I wanted to hear you say. And I don't even need the plus or minus. What I need to have you, and this one, please mark my words. If you take one thing out of all of this, remember this, memorize this, that if it's a vertical hyperbola, like if it's up down branches, then the slopes of your asymptotes are A over B.
So
If the hyperbola is a sideways hyperbola, then your slopes change to B over A. You might still be of the opinion that, oh, fine, just get on with it. Why do I care? You care because you're going to use that information to find either A or B, whichever one is missing. So having said that, let's talk about this. We know now, since it's a vertical hyperbola, that the slope is equal to A over B. Stop me if you're not with me because it's important. Now we're going to plug, how many variables are in that? Slope equals A over B. How many variables do you see in this egg? I see three. Slope is a variable, A is a variable, B is a variable. Well, when you look up here at these asymptotes, what are their slopes?
Three,
Three halves,
three
right?
halves.
So I say slope, I'm going to replace you with three halves. And then which one do I know, A or B?
B.
So then I'm
Six.
going to put 6 in place of B.
Yeah. And then A.
And then this is going to enable me to do some pretty basic mathematics to calculate A. And so you haven't probably solved one of these in a hot minute, but that thing in math has a name. It's called a proportion. And you would use it in this case to do math, but you could use it in the real world as like, three workers were able to complete two jobs in the allotted time. How many workers does it take to complete six jobs, right? We call that a proportion. People use it in cooking. I do it all the time. Like if I could get a recipe like for some green chili enchilada sauce and I want to not quite double the recipe, of maybe like 1.5 it, then I can use a proportion to scale up, the butter and the flour and all this different stuff, right? So it's a super useful concept in math. But the point is this, that what number has to go in the blank down here?
9.
It has to be 9. And we can reason our way through that because we just look at the problem down here. I'll put a relatively large purple box around it so that you can see it. We look at this problem down here and we just ask ourselves, sidewaysy, how did the bottom two become the bottom six? Tripled. So then take the top three, triple, and who do we now know?
A.
We now know A. So we now can say that A is equal to 9. And that's going to be probably the biggest tricky trick of all this because the sandbox doesn't really help us with that concept. It maybe can if you go nutso, like I think it was either one of these guys doing it yesterday when they drew all, I don't know if you were watching, you didn't probably see it, but they drew in like 20 dots. And it looked like at first they were just, oh, it's Anderson. Looked like,
What are you?
right. And it looked like artwork, but at the same time, yeah, he was drawing the asymptotes. And so maybe you could reason your A and B values from that. But that's the way I remember now always finding A or B.
How would we find it if
If
we just had the asymptote and not like a vertice or
if you only had the asymptotes and not a
co-vertice?
vertex or a covertex, I don't think you could do the problem. And I say that because there would be infinitely many values of A and B that have a ratio of 3 to 2, right?
So yeah, if you just had like a foci and
And again, if I had a focus, at least maybe then I could come back and try to proportionally narrow down what A and B are. But like you would agree, like in a problem like this, and I'm going to keep this short so I don't lose anybody. But according to this, could I have an A value of 15 and a B value of 10? Right. And if someone just left it up to me without locking me into some sort
Mhm.
of proportional, like I need a lock in, then it's just not enough information.
Okay.
Right. And that's why knowing one is so critical. If I know A, I plug them in to find B. If I know B, I plug them in to find A. But long story short, I'm done. So that's my experience with the Delta math is like the rest of them. And I'm not going to make this take any longer, but the point is, I think what you're going to find with all the ones where they give you vertices, co-vertices, foci, you can visualize those pretty quick. You can see A, B, C, and you can reason your way back. It's the asymptotes ones that are tricky. So this one, since it's vertical, then I would again do y first. So it would be y minus 2 squared. My second one would be x plus 8 squared. And then what's going to go under the first fraction? 81. Second fraction? 36. So I could keep going, but I don't really feel like I need to or want to. What I want to do is shut up, let you guys work, and then when someone says something like, "Hey, can you pull up my screen and can we go over this?" And the answer is, "You betcha." And don't forget with this one that the Pythagorean looking thing changed with the ellipses. Remember, it was a squared equals b squared plus c squared. With hyperbolas, it's changed back to look like the Pythagorean theorem. And this one is a squared plus b squared equals c squared. So when you're
Okay.
going to solve for a, b, or c, if you have the other two, note the different formula, right? All right, let's see if we can all get this assignment up to like 75% or 50%, even that.
6 or 7. Puzzle like a lot.
Please. Of course, I don't mind. No way.